In this particular example, we're asked to find the derivative of the relation 4x y cubed minus x squared y plus x cubed minus 5x plus 6 equals 0. This particular relation cannot be rearranged into the explicit form. Therefore, implicit differentiation must be used. This question is a little more challenging than the previous example because of the first two terms that appear in this relation. The first term is a 4x y cubed. If you look at that, we're really looking at the product of 4x and y cubed. It requires one to use the product rule because we're looking at the function f of x being 4x being multiplied by the function g of x y cubed. The same is true when you look at the second term in our original relation, the x squared y. The x squared is our f of x, and our g of x is y. So again, the product rule must be used. What I'm going to do in the next line is just work out the derivative of 4xy cubed with respect to x. So I've written d dx of 4xy cubed. To do so, I must use the product rule. So I have 4x, which is my f of x, times 3y squared y prime. The 3y squared y prime is my g prime of x. I add to that g of x, which is y cubed, times f prime of x, which is merely a 4. In my next line, all I've done is multiplied my terms, so I now know that my derivative of 4x y cubed with respect to x is 12x y squared y prime plus 4y cubed. I've done the same thing in the next line when I've taken the derivative of x squared y with respect to x. I'm using the product rule again. I have f of x, which is x squared, multiplied by g prime of x, which is y prime. I add to that g of x, which is a y, times f prime of x, which is a 2x. Again, I've just multiplied those terms together so that I have my derivative of x squared y with respect to x is x squared y prime plus 2xy. What I've done then is return to my original relation, and I'm taking the derivative of it with respect to x. I end up with 12x y squared y prime plus 4y cubed. That was my derivative of 4x y cubed with respect to x. I add to that x squared y prime plus 2xy. That was my derivative of x squared y with respect to x. I add to that 3x squared, which is the derivative of x cubed with respect to x. Subtract 5, which is the derivative of 5x with respect to x. Now it's simply a matter of keeping the terms with the y prime on the left-hand side of the equation and moving all the other terms to the other side of the equation. That's accomplished by subtracting 4y cubed from both sides of the equation, subtracting a negative 2xy from both sides of the equation, subtracting a 3x squared from both sides of the equation, and adding 5 to both sides of the equation. So that's how we end up with the final line on this particular screen. In the first line on the next screen, what you'll notice is we've common factored y prime out. So we end up with y prime times 12xy squared plus x squared equals negative 4y cubed minus 2xy minus 3x squared plus 5. Then it's simply a matter of dividing both sides of the equation by 12xy squared plus x squared, and we end up with our derivative. Please note that this derivative is expressed in terms of both x and y, not solely in terms of x, like was done in previous questions in which the derivative could be found using the product rule, power rule, or chain rule because the function was simply in its explicit form.